is Billy, and I'm doing the ELISA test.
And I'm Isaac, and I'm doing the immune system.
To start off with the ELISA test, you start off with a bunch of wells, and they're coated with specific protein to see if somebody has a disease or some sort. And then you put a solution of primary antibodies in the well, and the primary antibodies will attach to the proteins at the bottom of the well. And then you dump that solution out for the excess antibodies, and then you wash it out for any excess. And then you add another solution of secondary antibodies, and these antibodies have enzymes attached to them. And once you have those in there, you do the same thing as you did with the primary antibodies. You wash them out for any excess. And once you wash that out, you put in a solution of colorogenic substrate. And when you put the substrate in, if the substrate matches with the disease that's present, then the solution will change color, and the disease will be present.
Okay, and for the immune system begins when there's an unknown pathogen in the blood system. And when it enters the blood system, it signals to the neutrophil cell, which has the nucleus is not symmetrical, it's not any specific shape, and that releases the antimicrobial protein, or product actually, and that enters the pathogen to try to help kill it. And then if that doesn't work, then the macrophage comes and swallows up the protein or the pathogen, and doing that, it's trying to kill the pathogen before it enters the human cell, because if it enters the human cell, then it all goes bad. And floating around in the blood are the C3b proteins, and those also connect to the pathogen, and that's part of the complementary system. And if that doesn't work, the pathogen usually enters the human cell, and when it enters the human cell, it signals to the natural killer cell. And what the natural killer cell does, it also releases the antimicrobial product into the cell. But instead of just killing the pathogen, the natural killer cell also kills the human cell. So that's the worst thing. You kind of want all of this to work before that. And then also the B cell produces antibodies which connect to the pathogen. And sometimes you'll have particles of the pathogen that release off into the blood. And that's when the dendritic cell kicks in, and the dendritic cell swallows up these proteins, the proteins of the pathogen in the blood, and yeah.